Hello, everyone. My name is Andrew Yang. I'm the co-founder and CEO of Authenticiti. And first, I'd just like to briefly introduce what it is we do. So simply speaking, I'd say that Authenticiti is a framework for enterprise-grade blockchain infrastructure that's built on open-source Ethereum that focuses on three key things. One is the ability to deploy very quickly to any enterprise cloud environment or on-premise. All of our infrastructure is fully containerized and can be deployed very rapidly. Two is that we have data encryption and data privacy built into the network itself. So that means that any participant that's connected to our networks has complete unilateral control over their own data and is able to enforce very granular data sharing rules in terms of who they share that data with on the network, and of course the ability to revoke those privileges at any time. Three is a middleware layer that enables the ingestion of data from external sources, whether that's ERPs, document management systems, or whatever else, as well as the ability to support high volumes of actual data published to the network and propagated with other parties, whether that's PDFs of purchase orders, invoices, memos of shipment, or anything else. And so simply speaking, what we do is we help large industrials like GE arm their technical teams with containerized blockchain infrastructure, with all of the painful infrastructure maintenance and development abstracted away, so that they can focus on products that deliver real, tangible business value, instead of focusing on maintaining or building infrastructure themselves. We're currently in the process of deploying for multiple industrial OEMs and their logistics partners, and the use cases that we are focusing on in these deployments typically fall into three major buckets. And so the first of those buckets is trade finance or reverse factoring. The second is supply chain visibility or asset tracking. And the third is invoice dispute management or dispute resolution. And so today I'm going to walk through a quick demo that showcases three things. One is a live private Ethereum blockchain network with traffic being routed in a truly peer-to-peer manner without being first routed through a central server controlled by a single party. The second is an example of encrypted data sharing between peers across the network. And the third is a user interface that we spun up to support the use case. And to talk about the use case, I want to emphasize that what you're going to see is a hypothetical demo. But it's a trade finance use case that involves, hypothetically, three parties. One is GE Aviation, the second is one of their major aerospace customers, and the third is a financial institution. And so the idea is the customer can publish a purchase order to their node that gets propagated in an encrypted format. They grant access to Aviation to decrypt that purchase order. Aviation can then approve it, and then they can go through that same process and share it with the financial institution. The financial institution can see that valid link of the PO on the blockchain all the way back to the customer, treat it as valid, and accept it as collateral for early discounted cash flow, accelerating payment terms by 60 days. So going to the demo, what are you seeing behind me? What are all these flashing lights? Well, this is a user interface that we provide to the IT teams to monitor the actual health of the network. So in the bottom left, you can see the actual nodes connected to the network. Green means they've been synchronized with the latest transaction. Yellow means they're still synchronizing. And you can see other health metrics as well, such as the block time. So how long does it take for a block to actually get propagated across the network? Uptime, are these nodes healthy and synchronized? Do they have the latest transaction or block? And a map as well that showcases where the nodes are actually deployed. So some are on an AWS server in US West, others on US East. And if I go into the actual application itself, the first view we're going to see is the user account for GE Aviation. And what you're witnessing here is a chronological list of all the different transactions that have been published to the network. What is a transaction? Well, that can be any kind of data sharing event. That could be publishing data to the network. That could be sharing data, so decrypting it with other parties on the network. It could be a block being published. Every event or transaction has its own unique identity. That's duplicate proof. So that's a transaction hash, that string of letters and numbers here, as well as a lot of other metadata associated with it, such as, well, what we're showing here is the author and the timestamp. So if I go into the purchase orders view, I mentioned that this is a reverse factoring use case. So Aviation receives a PO from the customer, and they want to sell that as collateral to a financial institution. The data you're seeing here is data surfaced from a PO actually published on the blockchain network itself in bytes format. And you can see very basic fields such as the PO number, transaction reference, which is the unique identity of this particular document, and supporting documents as well that were contributed by other parties. So supporting documents are appended to the identity of the PO, and they're stored in a parent-child data hierarchy on the blockchain network itself. And that's what creates that digital history end-to-end across the different parties and the documents that they upload. And you can see here that chronological digital history stored on the blockchain from the creation of the PO all the way to the current stage that has been serviced from the blockchain itself. Now I just want to quickly go into an example of data sharing. So let's say GE Aviation wants to share an arbitrary PO number with the customer but not the financial institution. So they'll create the transaction. That should show up here. And there it is, green. OK, it's been synchronized with other parties on the network. So if I go into the view of the actual customer and I refresh the feed, if I go into the details and the metadata of the transaction, we can see that arbitrary PO number. However, if I go into the view of the financial institution who has not gotten access, they just see this string here, this line saying you do not have access. They didn't have the key to decrypt that data.